A small object is placed at the center of the bottom of a cylindrical vessel of radius 3 cm and 4 cm. So here it is a cylindrical vessel of radius 3 cm and height 4 cm. That means this particular dimension is 4 cm and here the radius of the vessel is 3 cm. And some object is kept at the center of the bottom of this cylinder. It is said height is 4, radius is 3. It is completely filled with water up to the top. One ray along the axis of the cylinder and the other ray leaving the vessel through a corner are used to trace the image of the object. Suppose we have got this particular point as the location of the object. So let us use one ray from this point along the axis of the cylinder. It is said that one ray is moving along the axis of the cylinder and the other leaving the vessel through a corner. So take one ray striking the corner of the vessel from the object, and this ray, since outside medium is air and here it is water, so outside medium is rarer, so light ray will go away from the normal, as this line is the normal to the surface of water, horizontal surface of the water at this point. So this light ray is moving away from the normal. Okay, let us suppose that I be the angle of incidence and R is the angle of refraction. So this particular refracted ray, when extended backward, intersect at this point. So let us suppose O is the location of object, then I must be the location of the image, because here it is one ray which is along the axis of the cylinder and the other one is leaving the vessel through corner. These two rays are used to trace the image, so common point of intersection is I. So I is the location of image. So let us suppose this point is A and this point is B. If it is used, let us suppose this is C. Okay. So if these two rays are used to trace the image of the object, ratio of the real depth to the apparent depth is. So what is the apparent depth? What is the real depth? Here you can see that real depth of this vessel is what? 4 centimeter, which is being denoted as AO in this diagram. Okay. And what is the apparent depth? Apparent depth according to this ray diagram is what? AI. AI is the apparent depth, and we have to find the ratio of real depth to the apparent depth. So this is our answer, that is we have to calculate. So here in the diagram you can see that this particular angle is equal to I. You can see directly these two angles are alternate angle, and here it is R, then this particular angle must be R, and we have to find the ratio of AO and AI. So you can see here that in these two triangles, the triangle ABI and the triangle ABO, in these two triangles the side AB is common. Okay, so if we write, suppose tan I for this particular triangle ABO, then what will be the value of the tan I? Tan I will be what? Perpendicular, which is AB divided by base. Base is AO. Okay, tan I is AB upon AO, and in the same way tan R will be what? Tan R will be perpendicular upon base, means perpendicular is AB divided by base is AI. Okay, if we divide these two, then what we get? Tan I divided by tan R is equal to what? Tan I is AB divided by AO. So AO reaches numerator, denominator. Okay, and AI comes to the numerator. AB and AB gets cancelled. Okay, so tan I upon tan R is AI upon AO, and we have to find AO upon AI, that means reciprocal of this. So in a way we have to find the value of tan R upon tan I. So tan I is known to us. Tan I in this triangle, if you see in this particular triangle, tan I, AB is known to us, AO is also known to us. AB is the radius, so tan I is AB upon AO. AB is 3 divided by AO is 4. So tan I here is known. So the remaining thing is tan R. So in other words, we have to calculate the value of R using Snell's law. So Snell's law is something that we haven't used so far. So let us use Snell's law for this. As we know, in case of Snell's law, mu sine theta remains constant. That means mu is the refractive index of the medium, sine theta, theta is angle with the normal. So here you can see that I angle is associated with the water and R angle is associated with air. So mu into sine of the corresponding angle, that thing remains constant. So mu of the water multiplied with sine I will be equal to the mu of air, which will take as 1 into sine R. So mu air is 1. So what is the value of the sine R? Sine R is equal to what? Mu of the water multiplied with sine I divided by nothing. So it's 1. So sine R is mu sine I. That means the value of sine R is equal to mu. Mu is 4 by 3, which is refractive index of the water, 1.33. Okay, so sine R is equal to mu. Mu is 4 by 3 into sine I. So what is the value of the sine I? You can see here the value of the sine I from this triangle ABO. This line is 3 centimeter, this is 4 centimeter, so hypotenuse has to be 5. So sine I is equal to 3 by 5. So we can write 3 by 5. So 3 and 3 gets cancelled. So sine R is 4 by 5. Okay, if sine R is 4 by 5, then what should be the value of the tan R? If sine R is 4 by 5, as you can see here in this triangle, suppose this angle is R and here it is 4 and here it is 5, then what should be the value of the base? 3. So sine R is 4 by 5, then tan R is 4 by 3. So tan R is 4 by 3, as you can see. So now let us substitute tan I as well as tan R in this expression. So what we get, tan I divided by tan R is equal to what? Tan I is 3 divided by 4 divided by tan R. Tan R is 4 divided by 3. So it becomes 9 upon 16. So AO upon AI in fact is tan R upon tan I. That means our answer is 16 divided by 9. So ratio of the real depth to the apparent depth is equal to 16 divided by 9, which is approximately same as 1.78. So in this question, option B will be the correct option.